I will be doing video number 7C. A 0.1 kilogram bead is allowed to slide along a frictionless circular wire, which has a radius of 5 centimeters, as shown above, or the diagrams are here. As the circular wire spins, the angle theta changes. At a fixed angular velocity for the wire circle, the bead is also moving in a circle. Calculate the radius of that circle as a function of theta, then calculate the angular velocity required for theta equals 40 degrees. So what the prompt is asking for is for us to calculate the radius of the circle in terms of theta. So we can do that. We're gonna make n be the normal force that is acting on the bead of this circular wire. If you do a force body diagram, you would get force of gravity minus force normal is equal to 0 if it was in the y direction, force of gravity and force normal of the bead acting on the wire. And the other component would be n sine of theta is equivalent to the centripetal force, which it can be which is mass times radius times angular velocity squared right over here. And so we're going to make the component of n, it balances the bead's weight, and the other component of n provides the centripetal force, which is, so this one balances the bead's weight and this one provides the centripetal force. So those are the two equations. And so we're going to solve for n in the first equation to get mg over cosine theta. Then we're going to plug that n into the second equation that we wrote to get mg cosine theta times sine of theta is equivalent to mass times radius times angular velocity squared. We solve that out, mass cancels out, sine over cosine theta, tan of theta, and you would get, you solve for r radius to get g tan of theta over angular velocity squared is equivalent to r radius in terms of theta. So that's the answer for the first question. Then the second question is asking us to calculate the angular velocity required for theta equals 40 degrees. Okay, so it's given to us that the radius is 5 centimeters, as stated, given in the prompt. And then we know that r is equivalent to big R sine theta. And we also calculated for r in the last prompt, which is, we just solved for that. So we can make both of them equal to each other to write out r sine theta, capital R sine theta is equivalent to g tan of theta over angular velocity squared. And so we're solving for angular velocity. So you isolate angular velocity squared to get g over r cosine theta. And then you plug in g for 9.8 meters per second squared. You plug in the radius, which is 0.05, because it was given to us in centimeters, and we had to convert that to meters. So we convert that to meters, we get 0.05. We do cosine of theta, which is cosine of 40 degrees, which is what they're asking for in the prompt. And you plug all of that in, then you square root both sides to isolate angular velocity, and you'd get 16 radians per second squared. And that's the answer to the second question. And this relates to what we've been learning in class, because we've been learning about angular acceleration and angular velocity, and we've applied that, like centripetal force and everything, we applied that in this problem. Thank you.